Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 32, multi-step problems. Classwork, opening exercise. Ian is buying beverages for a party that comes in packs of 8. Let P be the number of packs Ian buys and T be the total number of beverages. The equation T equals 8P can be used to calculate the total number of beverages when the number of packages is known. Determine the independent and dependent variables in this scenario, then make a table using whole number values of P less than 6. So this is a classwork, but a lot of it's been done for you. So P less than 6, number of packages P, total number of beverages T equals 8 minus P. From the prior lesson, you should remember that the variable that is all by its lonesome over here, all by itself, is the dependent variable. So this is dependent, and this is independent. Okay, so they've listed these for us. They gave us the equation T equals 8P, so T equals 8 times 0. 8 times 0, 0. T equals 8 times 1, 8. T equals 8 times 2, 16. T equals 8 times 3, 24. 8 times 4, and 8 times 5. So those are the calculations for values of P less than 6. Okay. Example 1. Make a graph in the opening exercise. Let's take it. We're going to graph these. So this is a really large grid, but we need to label our axes. So the first thing I would do is represent our axes as being right here. I don't want to take the time to get my ruler out and draw a nice straight line. This is fine. This is our y-axis, and this is our x-axis. X is independent, and y is dependent. So now we're addressing let me change my view a little bit. Let me zoom a little bit so I can see everything. There, that's good. Okay. So our independent variable will be our x-axis, and our dependent variable will be our y-axis. So here is x, here is y. We've got points before, and I'm going to use green to plot the dots so they're different than my axis. So number of packages P, 0, total number of beverages, 0. So if I don't have any packages, number of packages, you need to label your axes. Packages, and I'm going to put P here. So in this case, this is my P axis. And total number of beverages. Total number of bevies, and that is going to be my T. This is my T axis if you're using T and P instead of X and Y. Okay, so if I have 0 packages, I obviously will have 0 beverages. But if there is going to be 8 drinks or 8 beverages in each pack, 8 packs, if I have 1 package, so now I need to label what I'm doing here. 1, 2, 3, 4, 5, and that's as far as I need to go because we didn't use 6. And this is the origin, or 0. And this is 1, 2, 3. Now when I do this, there's going to be a problem here. I went up to 6, but my y goes to 40. 6 is way less than 40. This grid is not big enough to go all the way up to 40. So I need to change. And since I'm going to undo all that, but I wanted to show you that you have to be careful about your unit of measurement. And since I have 8 per package, why not make it easy and do multiples of 8 for what we are doing in the graph? So if we go like this, 8, 16, 32, oops, I skipped one, 8, 16, 24, try that again, 8 times 3, 8 times 4, 8 times 5, and 8 times 6. Okay, so 0 packages, 0 beverages. So now I'm just graphing these points, 0, 0. So that's an ordered pair. Remember doing those earlier in the year. So we're going to graph 0, 0, and that is the origin. And I'm going to go over 1 for packages and up to 8 for number of beverages in that package. Then over to 2 and up to 16, over to 3, and the answer, or the dependent variable, was 24 when the independent was 3, and when it was 4, the dependent variable was 32, and then when the independent variable was 5, the dependent variable was 40. So there is the graph. All we do is put dots on the grid. So we wouldn't connect a line. We not draw a line through these, because can we have half of a package? Probably not. So we're not going to worry about the in-between values. Okay, example 2. Now they're giving us a graph, and it says use the graph to determine which variable is the independent variable and which is the dependent variable. Okay, remember I told you that the independent variable is our x-axis, this is our x-axis, this is our y-axis. So number of hours is independent, and the number of miles is dependent. Number of miles depends on how many hours we were on our road trip. Okay, so now that I've done that, it says then state the relationship between the quantities represented by the variable. Okay, a relationship is an equation. So if we say number of hours h, now instead of using x and y, because we always use that for our axes, but in this case number of hours, this would be my h axis, and this would be number of miles m. Okay, so I know that we want to solve for m. M equals something times h. Okay, so 0 times 0 is 0. 0 times anything is 0, so that doesn't help me. But I then went over 1 and up to 50. So when h was 1, m was 50. So 50 times 1 is 50, and that's how I figure out what my rate of change is. Okay, so if you don't understand what I did, h is 1. So let me do that again. If we have an equation, m equals some value times h, and I told you that m was 50, and some number times 1 equals 50, then you should be able to tell me that 50 times 1 is 50, so therefore my equation, my value that I'm multiplying my variable by is 50, and that is called a coefficient, and in this case it is the rate of change because we're graphing. Okay, so 1, it's 50. 2, it's 100. So check it. If I have m equals 50 times h, m equals 50 times 2, and my m, when h is 2, my m was 100, does 100 equal 50 times 2? And yes, it does. So my answer is m equals 50h. That is the relationship between the two. Okay. Exercise 1. Now it's your turn. You try it. Pause the video. See if you can answer the question. Make a table, graph it, and then come back and see how you do it. Okay, here we go. Number 1 says, each week, Quentin earns $30. If he saves his money, so each week he earns $30. If he saves his money, create a graph that will show the total amount of money Quentin has saved from week 1 through week 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. Did I do that right? 1 through 8. I'm not sure why they gave me so many lines, because I think they only want to go up to 8. 1, 2, 3, 4, 5, 6, 7, 8. I guess this is not necessary. Their title goes in the first one. And so each week Quentin earns $30. So that's going to be number of weeks. Let me just use the number symbol. Hashtag weeks. Number of weeks. And we're going to create a graph, show the total amount of money. Money. Total saved. This will be total saved. Okay, and that is going to be dollars. So in dollars. So dollars. There, that's better. Number of weeks, total dollars saved. Okay, so we're going to choose 1 through 8, like they asked us to, right here, week 1 through 8. Write an equation that represents the relationship. So each week Quentin earns $30. This is the independent variable, this is the dependent variable, so total equals, totals by itself, and $30 per week. And there's my equation, T equals 30W. So when W is 1, 30 times 1 is 30. So 1 week he makes $30, 2 weeks he makes 30 times 2, 30 times 3, and so on. Okay, so now when I label my grid, I want number of weeks, W, so this is my W axis, and this is going to be my y-axis, which is my dependent variable. That's pretty sloppy. Difficult to draw this with this board. Okay, and that is going to be total saved. Okay. Total saved. All right. Now we have to determine a unit of measurement. So we're going through. So this is 1, 2, 3, 4, 5, 6, 7. Okay, so this doesn't fit. Okay, unfortunately they aren't giving me the right grid to do this. Or is it up here? No, that's road trip. So this is the wrong grid. I hope yours is a different grid in the student manual. Let me go look at that. Okay, I just looked at the student manual online and it looks like this is the same grid. They aren't giving us enough squares, so I'm going to adjust this so we're not worried about week 0. So I'm going to start at 1, 2, 3, 4, 5, 6, 7, and I will have to extend this out to 8. Okay, I apologize for that. I did not create this PDF, but we're going to have to go out to 8. So I'm trying to decide whether or not I would even want to start at 1 in the corner. Well, let's do it anyway and see what happens. So we want to go up to 240. So actually that should be 0 here, and hang on. Okay, so I just saved you some time. I fixed this. I added another one number of weeks here. I start at 0 and I'm going over to 8, so I needed 2 more grids. You probably need to do the same thing. And then to go up to 240, I need to go up by my variable. So this is going to be 30, 60, 90. It's just easier to graph if you do it this way. And then 180, and then keep going up. Okay, so this is becoming a problem because now I can't go anywhere near this. So let's just graph what we can fit for now. So week 1, $30, week 2, 60, week 3, 90, week 4, 120. So you get to see what's going on here. This is going to keep going up to here, so it doesn't fit. But as you can see, it's a constant increase, constant rate of change, going up $30 every week. Okay. Again, I apologize for the wrong material to do this problem, but it'll be okay. Okay, here's example 2, or exercise 2. So I'll try it again. Hopefully they gave us the right graph this time. See if you can do this, and we'll come back and take a look. Okay, so here we go. So we have B equals 2W plus 3. They gave us the equation. B is my dependent variable, and dependent is over here, and independent is over here. So this is B, and this is W. It's the easiest way to do this. And B is total number of books. And W is number of weeks. And when I do my axes here, drawn the best I can. Alright, and so X axis is independent, so this is my W axis, and this is my B axis. So if I graph this, then this will be the number of weeks. It's very important you label each side of the grid, and this is total number of books collected. Okay, so now I need to, it says when W is 5 or less, so 5, 4, 3, 2, 1, and 0. So we could collect no books in this case. And, or number of weeks 0, I guess. Okay, so 5 or less, and then we want to label our diagram 0, 1, 2, 3, 4, 5. This would be 6, but we don't need it. And then now we have to do our calculations, which is B minus 2W plus 3. And if I know that W is 0, B equals 2W plus 3. B equals 2 times 0 plus 3. So B equals 0 plus 3. B equals 3. So that's 3. If I change this to 1 right here, change that to 1, 2 times 1 is 2. So then I would just have to change this here. And this would be 2 plus 3. So that would be 5. And once we do a couple of them, multiplications, repetitive addition, we're only adding 2 each time. So 3, 5, 7, 9, 11, 13. We're done our table. Now we just have to graph. Choose a different color. And so week 0, we had 3 books. We have to go up to 13. So how about we go in increments of 2 and try that. 2, 4, actually let me use the same color. 2, 4, 6, 8, 10, 12. Okay, we need to go a little bit higher and then come over here one more level up. So they didn't give us the right graph to fit this by 2s. And this is a scale of 2. I'm using the number that's in front of the variable for my scale here. And in order to get to the last one, 13, I'm off the grid a little bit, but that's okay. So I'm going to graph 0. So 0 weeks, we're going to collect 3 books. 1 week, we're going to collect 5 books. 2 weeks, we're going to collect 7 books. Week 3, 9. Week 4, 11. And week 5, 13. And there is. Okay, last one, number 3. Try it, pause the video, come back, see if you did it correctly. Okay, so let's take a look at this. Eliana plans to visit the fair. She must pay $5 to enter the fairgrounds. That is a constant. And an additional $3 per ride. Write an equation to show the relationship between R, the number of rides, okay, R, number of rides, is my dependent variable, or independent variable, I'm sorry, independent, number of rides. So let's see, number of rides. That is, I was right the first time, that is my independent variable. My dependent variable is what's up. Dependent variable is what's by itself, and that will be T, total cost in dollars. Okay, so it says state which variable is dependent and which is independent. So the independent variable is R, the dependent variable is T, total cost. Calculating T, we calculate the independent variable. Create a graph and model the equation. Okay, so we're just going to do, let's see, we could go to a fair and not ride any rides. We could ride 1, we could ride 2, 3, 4, just do this. Okay. Next thing I want to do is draw my axes. Okay, and X is R, so this is my R axis. Y is T, so this is my T axis. This is 0. And then I just calculate 1. I just use a unit of measure. 1 unit per grid. So 1 unit per square, 1, 2, 3, 4, 5, 6. And going up the side, we are paying $3 per ride, so I want to do multiples of 3 possibly. So let's see, we want to go up to, let's think about this. So if I plug in 5, let's do a calculation first before we just think about what we're going to put here. Down here is the independent variable, and that's going to be number of rides. And over here is going to be total cost in dollars. Okay? Alright, so I have to come up with an equation. She must pay $5 to enter the fairground. So if I go to the fair and I have a total cost, and total cost equals $5 to enter the fair, that's a given. Okay, and an additional $3 per ride. So there's my equation. T equals 3R plus 5. I'm just going to plug these in now instead of showing all my work. 0 for R will be 3 times 0, which is 0, plus 5 is 5. So if you go to the fair and don't ride any rides, it's costing us $5 to enter, and that is it. And if I go up to, let's see, I just want to see what I'm going to get if I plug in 1. So if I plug in a 1, if I ride 1 ride, 3 times 1 is 3, plus 5 is 8. So I'm increasing by 3 every time, so this is going to be 11, plus 3, plus 3, plus 3. So my biggest number on my t-axis is 20. So if I go 5, 10, 15, 20, I can do it that way. And it's multiples of 3. 3, 6, 9, 12, 15, 18. Then we get onto the grid. I'm going to do that. 3, 6. Actually, let me think. Yeah, 3, 6. Then I don't have my values right on the grid. So I guess that's okay. 3, 6, 9 is kind of as much as possible with that constant. 3, 6, 9, 12, plus 3 is 15, plus 3 is 18. But I have a 20 here. So I could just go up to 18 and grab those. Change color so you can see it. So if I go into the fair and don't ride any rides, it is costing me $5. So that's about here. Maybe a little higher. And 3, 4, 5, and 6. If I ride 1 ride, it is $8. Here's 6, here's 9, so 7, 8's about here. It's 2/3 of the way up. And 211 is here. And 314 is here. And 417 is here, and you get the idea. 520 would be about here, but it's off the grid. Okay, so there's our graph, nice straight line, and it's costing us $5 if we don't ride any rides, and $3 more for 1 ride. Okay, that is the end of lesson 32. Go to your problem set.